Hi, I'm Matt Rosen. I lead a research group at the MGH Martinos Center. I've been there for about 12 years, and my group mostly focuses on new and novel approaches to magnetic resonance imaging. The name of my laboratory is the Low Field MRI and Hyperpolarized Media Laboratory. That's a big name. Let's just break it down into two pieces. The first part is low field MRI. So MRI, of course, is a great medical success story. These are typically massive, very expensive machines, partly because they operate at very high magnetic fields, Tesla strength magnetic fields. So what we do in my group is turn down the magnetic field, hence low field MRI, to make more portable and cheaper scanners. The second part of the name is hyperpolarized media. What hyperpolarization is it takes angular momentum. Angular momentum you normally think of like someone on a swing. So we transfer angular momentum from places that we have it, like photons and light, to places that we want it, like the spins in the nucleus of, say, water. The nuclear spin, which is what you measure with MRI. Operation at low magnetic field not only means that you have a cheaper scanner, but you also have a scanner that is able to be operated outside of the controlled access radiology suite of a hospital. Again, these large magnetic fields, if you think about taking an MRI scanner to an uncontrolled environment, let's say like a military field hospital, you might have someone who needs a head MRI but might have shrapnel in their body. And so by putting them in a large magnetic field, you might have a problem. So turning down the magnetic field enables operation in a portable, widely accessible manner. We've commercialized some of this technology, and so you can actually now get a bedside MRI scanner. There are two over in London that are used in the neurocritical care unit, and it's so amazing really to see the trajectory and to be involved in the trajectory. That spans back 20 years really, developing these ideas with conversations with clinician scientists and then bringing this out into the world for people to use as a tool. I'm really happy that I received the 2022 Research Scholar Award from the MGH Research Institute. The MGH Research Scholar Award allows me to kind of tack and take some of the ideas that we've developed for neuroimaging and see if we can apply them for breast imaging. And this is a really interesting approach because there's a lot of very interesting physics which has to do with what we call magnetic relaxation, which are tissue properties for both healthy breast and cancerous breast tissue that are different from each other. And those differences actually are more significant at low magnetic field than they are at high magnetic field. So not only are we potentially developing a low-cost screening tool for breast cancer that is much more pain-free than mammography, but in fact the results may in fact be more diagnostic. So the MGH Research Scholar Award is allowing me to now spend a few years thinking about this new idea for women's health and public health focusing on breast imaging. I'm a bass player, electric bass player, and I play classical music from North India, an instrument called the sarod. One of the things I've been doing during the pandemic is I've gotten back in touch with my old band, who we live in 3 separate states. And we all met in high school, and one of the kind of most important events in our collective musical experience was hearing a band together in the early 80s called the Objects. And the Objects were a band from Hoboken, New Jersey, an amazing band that released a single cassette and sort of disappeared. No one's really heard much about them. We got this idea during the pandemic, we could re-record that album. We could cover that entire album. We've learned a lot about technology and Zoom during the pandemic, but also at-home recording is so accessible now, very different from the way we used to record to multi-track reel-to-reel tape in the 80s. And that's been a really kind of entertaining way to spend time when I'm not in the laboratory. So I'll record my bass parts, send them down to the guitar player, he'll mix them, send them back, they go up to the drummer records his parts, and it's been a lot of fun. Really learning how to create things as part of a team. So we're a trio, and bouncing musical ideas off of each other. It's not that different from sort of bouncing scientific ideas off of, again, a very close working relationship type of team. I do experimental physics, and I think a real key part of that is fleshing out ideas and communicating those ideas with the research team as they develop. And that's a skill that frankly I think I learned as a child playing with my 2 best friends in a band. And so learning to communicate musical ideas communicated in language, right, in words, and let's say science or physics ideas communicated in language. Again, different domains. Like there's the domain of physics and equations, and then there's the domain of language. So connecting these domains is actually really interesting. Domain transform is kind of an interesting I guess theme in my life. I hadn't really appreciated that.